All right, let's work through some practice problems for circular motion. We're going to look at 3 different questions today off of the practice assignment. The first one is question number 6. And this question, the main focus here is that it's going to ask us to take our velocity and convert this from meters per second into RPMs. I realize this is a new conversion, so I wanted to make sure that I work through one of these with you. And I'm also going to show you how to manipulate the formula to solve for velocity. This is a variable you're going to be asked to solve for quite often, so I thought it might be helpful for you to see how that's going to work out with the algebra by itself, so that you can choose to maybe just jump to that in the future. All right, so it says, how fast in RPM must a centrifuge rotate if a particle 7 centimeters from the axis of rotation is to experience an acceleration of 125,000 Gs. So my givens in this problem is that I have a radius of 7 centimeters. Now I'd like for you to recognize that we cannot use that in our calculation in the form of centimeters, so we would have to divide by 100 or move your decimal 2 places to the left, whichever you're more comfortable with. And so we're actually going to use a value of 0.07 meters in our math work. The next variable that they give us is acceleration, and they give this to us in terms of G's. So what that means is that I am going to need to take my 125,000 and I'm going to need to multiply that by the value of G, which is going to be our 9.8, in order to get an actual value in meters per second squared. So I'm going to need to do a conversion here. Now, most of my students would probably prefer to go ahead and grab their calculator at this time and multiply that out. I'm actually going to choose to do it later on in my math work, but I put a note here to myself that this does need to be converted in meters per second squared to remind me when I plug in my numbers later that I need to account for that. They're asking us to solve for the velocity. So in this question, we're going to use A equals V squared over R. Now here, once again, most of my students would probably prefer to go ahead and put their numbers into the math work and then solve. I'm actually going to show you how to do it with the algebra first. 2 reasons for me doing this. Number 1, I really need you guys to be capable of manipulating the formulas without the numbers plugged in. As I've said several times, there are going to be some questions where you don't have enough information right off the bat to plug in your numbers and begin calculating. You're going to have to perform some algebra to manipulate some variables, maybe eliminate some variables in order to see how that problem is going to be worked, or in order to realize that you do have enough information to work it. So this is a skill that you guys need to be building. Number 2, we're going to be asked to take this formula and rearrange it to solve for velocity fairly often. So if you get comfortable with understanding how to do that, then you can go ahead and jump to that rearranged version much sooner in your math work for future questions, which will just hopefully help you to complete the problem a little faster. So if we are solving for our velocity, that means that I'm going to need to multiply both sides by r. So then I have v squared equals a times r. And then we're going to need to square root that in order to get it to be v all by itself. So v is equal to the square root of r. Okay, now I'm going to choose to plug my numbers in. So v is equal to the square root. Now again, my acceleration needed to be converted by multiplying the number they gave us times the acceleration due to gravity. And that number in meters per second is being multiplied by the radius. So here's how I chose to put my numbers in. Once we get this in our calculator, we get a value of 292.831, and then there's more digits in my calculator. Now this is calculated for us in meters per second because that's what the formula calls for. This particular question, though, wanted me to convert this into RPMs, which stands for revolutions per minute. So now I'm going to show you how to do that conversion. We have 292.831 ... Now this is in meters per second. So I'm going to set up a conversion fraction. I am going to choose to do the distance first. So I'm going to convert from a distance in meters into a revolution. So a revolution is just simply one trip around the circle. So it's essentially a form of a distance if we say how far around that circle it is, or if we are able to provide the circumference of the circle. So that's what we're going to put here. So the formula is that 2 pi r, one trip around the circle, is one revolution. So this is how I'm going to set up my problem. Now, since we're actually converting a value here, I'm going to go ahead and replace my r with the 0.07 meters that we had in the original problem. So this is how I know that 2 pi r goes in the side with the meters, because my radius is in meters, and that's where the meters comes from. So my meters is going to cancel. It's going to leave me my distance in revolutions, and so now I need to convert my time in seconds. Seconds is initially in the denominator, so I'm going to put it in the numerator so that now it's being divided by itself and it will cancel. I'm going to go from seconds to minutes. And so this is my conversion fraction. So I'm simply going to multiply all of these things across, or I could say that I'm going to multiply the top and then divide by the denominator. I did give a friendly little reminder, or I guess instruction, initially when I taught this, that you should probably put that 2 pi times 0.07 in a parenthesis. You need to instruct your calculator to use all of that as the denominator. If you fail to put it in parentheses, what happens most of the time is that your calculator is following order of operations, so it's most likely going to divide by your 2 pi, and then it's going to take the answer and multiply by 0.07, which is not what we need it to do. So make sure that you are understanding how to work your calculator properly. All right, so now that we have our velocity in revolutions per minute, we're going to go ahead and round for sig figs. And so here is our answer to number 6. All right, now we're going to look at question number 8. In this question, we are being asked to perform a calculation where we have to understand what is serving as that centripetal force. So just a reminder, in general, in order for an object to experience an acceleration, it must experience a net force. If that acceleration is simply to turn the object so that it makes a circle or a portion of a circle, then we refer to the force that turns it or that creates that circle as the centripetal force. So I have up here that the centripetal force in this case is the same as our net force, and conceptually that is true for things going in a circle. But in this particular question, this is a vehicle that is turning, and we discussed in the lesson that the force applied to the car to cause it to turn is actually friction that comes from the tires touching the road. So our frictional force is going to serve as the net force or the centripetal force that causes this car to make that turn. Okay, so if we were to draw our free body diagram, vertically my car is in equilibrium on the road. Horizontally, it only experiences the one friction towards the center of the circle, and that's going to serve as the force to make it turn. So how large must the coefficient of static friction be between the tires and the road if a car is to round a level curve of radius 125 meters at a speed of 95 kilometers per hour? So I have a radius of 125 meters. I have a speed of 95 kilometers per hour. Once again, we are not going to be able to use this. We need to convert this to meters per second. And so once we do that, that is going to give us a value of 26.38, and then my 8 is repeating. They are asking me to solve for my mu. So, two things. First off, let's start with the basics. The net force is responsible for creating the acceleration. And in this case, the net force is the frictional force. There's only one force value there. So we can replace F net with F of F. Now this question is asking me to solve for my coefficient of friction. Coefficient of friction is currently not in my formula, so I need to figure out what part of this relationship is related to mu so that I can use that relationship to rewrite my formula? Well, we're supposed to know that the frictional force is mu times the normal. So my frictional force will be replaced with mu times the normal, and if we look at our free body diagram here, our normal force is the same as the weight in this particular question. So for our normal force, we'll just plug in whatever m times g is. So this is the equation that tells me the relationship that I need to know in order to solve this problem. So whenever we get ready to solve for our mu, we are going to divide both sides by m. So my m's are going to cancel. And we're also going to divide both sides by g. Now this a and that g are not the same variable. So I'm going to write it like this. Okay? Now conceptually, that is what's supposed to happen. But let's look at our variables that we are given on our list over here. I don't have an acceleration rate. So for me to work the problem like this is a little bit of a challenge because I need to go and find my acceleration. So at this time, you could go off to the side and you could say A is equal to V squared over R, and you could perform the calculation to solve for your acceleration and then put it into the problem. Or what we could do is we could, let's go ahead and say that we canceled out our masses since we know that's going to happen either way. And we can say that instead of saying mu g is equal to A, we can just replace that with V squared over R because they are equivalent. So now when I divide by g, I end up with mu is equal to V squared over GR. And now I can simply plug in my numbers and solve for mu. My V is the 26.38 repeating. Please, guys, when you put this in your calculator, will you please ask your calculator to use the previous answer and then follow that up with the x squared button? And then ask your calculator to divide by the denominator. You also want to tell your calculator to put all of this denominator in parentheses so that your calculator understands that all of this together is going to give me the one value for the denominator. So once we do that, we get mu is equal to 0.56846 ... So we're going to round this for sig figs. 0.57 is our answer, and remember, mu does not have a unit.